Hello, my name is Seungwan Lee, and I'm gonna brief review about second week's lecture. First, I'm gonna talk about MOSFET. It is consist of source, drain, and gate, as you see in this picture. What is different from other transistor is that it has SiO2 layer under the gate. It also acts as like switch. If we give bias on gate, it will act as short circuit, and the current will flow through each channel. As you see in this characteristic graph, it has three types of region. First is triode region. In this region, as much as we give gate source voltage, drain current will rise right before the saturation region. At saturation region, drain current does not increase, although we will give bias of gate source. Second, I'm gonna talk about CMOS. CMOS consists of PMOS and NMOS. It operate as like an inverter. If we give zero input, the output will be high, but if we give one input, output will be low, and the result is here in the graph. And for third, I'm gonna talk about device scaling down. In this section, we have to focus on DIBR effect, which is abbreviation of drain-induced barrier lowering. DIBR effect is as the channel length is decreases, the more obviously it will affect. And next is SOI and multi-gate. There are two types of multi-gate. One is bulk gate and the other is FT-SOI. Bulk gate flows current even it is off state, but it is more widely used because it is cheaper than other gate. On the other hand of bulk type, FT-SOI type is very useful in short length channel, and also current cannot flow even each state is off. But due to each processing, it is more expensive than other gate. So it is only used in the field of space program or military devices. And next I'm gonna talk about memory. There are several types of memory. First, SRAM is 60-cell transistor. It has high speed and static when power is applied. It also has very low power dissipation. Other type of memory is DRAM. It is 1T cell. It is slower than SRAM and refresh is needed, and it also has power dissipation. Last is flash memory. It is slower compared to SRAM and DRAM. What you have to focus on this section is quantum tunneling. And next is VNAND. And VNAND is abbreviation of vertical NAND. As you see in this picture, this NAND structure is vertically designed. This vertical structure increases its integrity of NAND flash memory. Samsung and Toshiba uses this NAND flash memory. Today, and for next, I'm gonna talk about scaling down. If we reduce feature area by 50%, its power will reduce approximately 20%. For this result, its performance would increase nearly 20% and its cost would decrease up to 15%. So it is really important to scaling down each size of feature. As you see in this picture, SO2 exists not to flow leakage current to other transistor, as you see in this picture. Finally, I would like to introduce about lithography, which is very important in this part. Lithography is one of the process of making silicon wafer. Now, I would like to introduce about lithography process. First, photoresist material is spin coating on the surface of wafer. Second layer which is spin coated would exposed by ultraviolet ray, electrons and X-rays. At this moment, tool, mask, and computer data would decide which part to expose. Third, depend on the PR layer's resist type. In the process of development, it will remove exposed of non-exposed area. At this time, the part that you want to remove would be removed by melting by developer. Fourth, by remaining PR layer that is on the wafer surface, it will conduct doping process or etching process to etch wanted part. To explain specifically, at positive photoresist, exposed part is easy to dissolute by developer, so it will form positive image. On the other hand, of positive photoresist and negative photoresist exposed part does not dissolute by developer. Both of the method is using in the field of wafer fabrication, but positive resist has better resolution than negative resist, so it is widely used. Thank you.